Hi, everybody. I'm Sharbani, and I look after AI platforms at ARM. In my day-to-day, I'm obsessing over how my teams and I can help developers get efficient models everywhere. So that's up and down the stack, from cloud to edge, and to make sure that we're helping them build and productionize models and integrate AI workloads into meaningful applications that solve real-world problems that drive your businesses. So today, I'm going to put a little more of my strategy hat on for you, maybe do a little bit less of a technical deep dive, but cover a little more about how we're not just thinking about the local minimas for efficiency, but also about how you're designing for efficiency at your applications, your systems, and your overall businesses. And if you have any gripes, complaints, kudos, or problems that you're working on, my UX researcher, Giannis, is here today representing our team, and so he's here to intake anything that you want to tell him, just a call to action. All right, so we talk a lot about massive models and scaling laws, but the real game changer might actually be small AI. So spoiler alert, that's what I'm going to dig into a little bit today. Smaller, leaner, smarter, open, and closer to us. But models that are easier to access, easier to make more useful for our daily lives. And how do we get there? That's through efficiency. And when inference is lightweight and optimized, it runs where connectivity is limited, keeps data local, and uses less power and helps speed up faster responsiveness of UX. And this means AI doesn't just reach, but it can be usefully integrated into our everyday lives. And useful doesn't just mean what these beautiful images that my design team put together for me for this presentation, thank you very much, but it actually means things like the real human problems that we need deeply useful solutions to help us make the most of our daily lives. So most people don't really care what your application does or what's running under the hood. Your actual consumers care what it does for them. And so when I'm building, even if it's just about improving your KTLO, this is my goal, is to make you feel like this. Do y'all want to feel like this? I do, right? So a quick ask for you once this talk is done. I caveated, I'd love to hear from you. I want to know what your biggest problems are, what you're actually working on today. So come talk to me, come talk to Giannis, come to our booth. And I want to know, how are any of the topics that I'm about to dig into helping you or actually blocking you? So since Gen AI exploded a few years ago, the most performant way to integrate AI into applications has come from large models, consolidated into a few large players, usually offering access via hosted LLMs with an API structure. And these larger models have led to distilling small Gen AI models with strong performance improvements, accelerating even over just the last few months. I'm sure many of you have seen the different papers that have been coming out in blog posts and opinion pieces. So when it comes to building these useful AI applications, there is an emerging fork in the road. What type of model do you use? So I'm simplifying this choice into large and small, just for the purposes of this talk. Large models are centralized, they're expensive and complex, and they require giant supercomputers to run on. And actually, to give you a sense of scale, I mean, we saw a bunch of this covered today in today's keynotes, but training today's frontier models actually takes the equivalent power of a small city. And inference is a whole operational challenge. You know, even just keeping the lights on is massive, requiring data center-wide deployment demands and sophisticated cooling and power management. Now, large models have been driving toward AGI, but you don't need AGI to be useful, going back to the everyday tasks and innovation. And that's where I think small models can really, really shine. And usually, for the purposes of this discussion, we're going to talk about open models. These can be fantastic, right? Small transformer models, such as Llama ones, which will really put a stake in the ground for open models, for the most part, can be trained on your downstream tasks, which we'll get into a little bit later. Now, once again, thinking about efficiency, let's zoom in on inference. So inference is where you really need to have a good understanding of your architecture and for the economics of your model and for the businesses that you're building. So generally, training is where you're spending your money up front, and inferences should be where you're making it and scaling. But if you aren't thinking about efficiency, how might this compound a cost structure that can get out of hand? Anybody feel like your costs are getting a little harder as you're scaling your products? Everybody's just got money flowing in, money flowing out, it's all good? Okay, cool. So how does this work? The large model builders, they're usually obsessing over performance per dollar per watt. And then for most of us who are not centralized, we're using APIs, paying a per token usage of the model. How many of you are How many of you are actually working off of a token-based structure today? And how many of you have your own? Yeah, great, perfect, okay. So for small models, that means that you're looking after your own infrastructure, but they can also be more controllable. They're running on your device or your desktop, putting the models that are at your customer's fingertips. So you also have the advantage of being able to fine-tune them for specific use cases. And I'll dig into some of the classic benefits of edge AI, like privacy, latency, connectivity, et cetera. But first, I want to dig into further how we can move from the economics of a single model call to a more sophisticated, complex agentic workflow. So let's take a quick example. Maybe not so quick. Say I want an agent that can search, book restaurants for me, and one that takes the cognitive load away from me. So for example, tonight, I don't know who's going to dinner with me, but I want a healthy restaurant that is open after 9, that can handle a friend who has severe celiacs, one who's training for a half marathon, and one who does not believe in vegetables. And I know there's some of you here in this room. And it needs to be walkable. And I could do that myself with a lot of Google Maps searching, and not just the distance, but also the hills around here. But how would an agent do that for me? How can it take on that cognitive load for me? Well, the first part is to understand my intent, and there's a lot of parameters in there. Restaurant type, time of opening, distance, particular dietary restrictions, preferences on mode of transportation, willingness to tackle those hills. Now, once my agent has the intent, they need to make a plan. So maybe they Google search the parameters I mentioned, but how am I going to know what the right tools are? How many of you know what the right tools are? Who wants to solve this problem for me? Well, fortunately, there are a lot of tools. There's probably too many tools to search for what I need, and I have a lot of preferences. First, my agent might need keywords for search, and the search will be a tool. But the search finds websites, right? And those websites might be restaurants, but they also might be review sites or influencer sites or enthusiast sites, whatever. So it takes another tool to browse and understand those sites to be restaurants that serve what I want, and that's another tool. And then to browse those sites to see if they have the actual menu items or whatever else I've actually asked for. Understanding all of those nuances, each of those is a whole nother tool, right? So when it's done, my agent will need to reflect on everything that it's done and see if I got sufficient results. And that's not generally just for my needs and preferences from a very small prompt. And if it didn't, well, like everything else, it's time to change the plan. I have to repeat the process. And now I just have a quick side note. When I'm thinking about designing agents, especially if I were to dig into multi-agent orchestration, I think a lot about organizational behavior. If I have a team of real humans, what do I expect to get from them realistically for various experience levels and roles? Do we have people running teams or mostly like individual contributors in the room? Just like think about all of the work that it takes to think about what levels you need, the skill sets you need, like just writing those job descriptions is a pain. Basically, you have to be thinking about that when you're thinking about how your agents, what they're gonna do, what you need from them, what kind of artifacts you can expect from them, what type of judgment calls you need them to be able to make. You have to think about all of that up front. Okay, so back to the topic at hand. My little tangent. Economics. So, let's rerun this flow looking at the cost structure. So again, we were talking about tokens. So to understand my original intent, we needed to use an AI model. And assuming that you're running a hosted model, that costs tokens. Cool. And then once my agent has intent, it needs to make a plan. It has to go back to consult the model. And yes, just like a good consultant, it costs a token every time you go back. So you have to solve another piece of the puzzle every time you have to pay for another token or set of tokens, no matter how big or how small. Even the simple scenario that had a lot of tools it needed to use, and each time you go and consult the model, talk to another tool, it costs more and more tokens. So maybe it's generating code to call an API or parsing those results that come back from it, like my Google search for my restaurant. Or maybe it's downloading contents of a web page and understanding those contents, and then finding the menu page, et cetera. But each of those costs tokens, more tokens. You guys get the idea. So then if you reflect, you go back and you match the results to the intent, and you guessed it, tokens. So more tokens. You need even more tokens if you replan, right? So you guys get the idea. So the main point here is yes, agents are amazing, and using hosted models come with a whole number of benefits. But after you walk through all the steps and you see using multiple model calls, it adds up to a lot and lots of tokens. So for your many use cases, would it be better for you, thinking about those use cases I asked you in the beginning, if you could have control of your own model so you aren't having to pay a third party per token usage fee? Well, I think it's a great way to start small and iterate fast without incurring massive costs. And beyond just the economics of it, it's not just about where the model runs. It's about what kind of efficiency it delivers and how good is your UX. Is it fast? Is it near real time? Is it relevant to my specific needs or context? And on the left here is a super artistic visual. I did not have the design team help for this one, about the visual of the classic cloud setup for your data flows from the device through the network, up to the data center, into a big hosted model, and then all the way back down again. That's a lot of hops, right? This is a local small model on the right. Again, beautiful artistic representation. It's entirely on device or desktop. And everything's local. It's a smaller model that fits on your device, but there's no round trips and no dependencies. So less hops, lower latency. And latency is really, going back to thinking about the product strategy, is the heart of the user experience. When you think about what you're building and you're thinking about real-time experiences, how many of you are thinking about a real-time communication experience or something that needs to be near real-time? Yes, I know several of you are. When you think about that, whether it's visual, voice, haptics, your end-to-end latency for the entire experience has to be around 300 milliseconds or less, and that's for everything. That's your ceiling. Anything above that, and you start to feel real lag, and your customers notice that. For voice and haptics, it's actually even tighter. And now when you think about agentic workflows where multiple models or experiences are interacting in sequence, if you have to make a cloud call, then you're quickly stacking up on those delays. And running locally helps keep a feedback loop on that really tight. So you get instant responsiveness, which translates directly into great UX, which translates into more engagement and more end users. And you also have less calls to the data center, so fewer tokens, lower cost, but it's also about scaling efficiently. So on device, you pay once. The model's there, and it's optimized for your hardware. You can run it as many times as you want. It's not just about saving money. It's about scaling sustainably, freeing up data center resources for heavier shared workloads, and letting lightweight, high-frequency inference happen locally. And it's more useful, or it can be more useful. This is where privacy and personalization come in. So the most useful agentic experiences are the ones that can access your private, proprietary, contextual information, your calendars, your messages, your files, but securely and with the most up-to-date information. Right, if the data's leaving the device, then it introduces risk and friction. And when inference happens locally, then the model can still use that data without ever having to expose it. And that's what makes our agents not just smart, but trusted and truly personalized for you and for your users. And then obviously there's availability. When you're going on device, you don't have to worry about the connectivity. This is the efficiency that we can unlock by running AI closer to the user at their fingertips. And this is what enables agentic experiences that are fast, private, and always on. So to fit on a device, we have to go back to small models. You need something that can actually fit on the device, but you also want to have more fine-grained control from your small models ahead of time. You need to be going back to those problems that we talked about and make sure that you have the right data for the specific problems that you're solving. And generally, when focused on specific tasks, we're seeing incredible performance from small language models. These models, many of you have been probably reading the literature, we're seeing that they are outperforming large general-purpose LLMs on specific tasks, particular in NLP, classification, summarization, and other benchmarks. And we're seeing incredible performance coming out, ranging from the 80 billion parameter Quen model to Samsung released a few weeks ago, the tiny recursive model that's weighing in at 7 million parameters, which apparently totally crushes it in Sudoku and a few other things. Yeah. So for those of us who have been building software applications for a long time, at least for me, I know that I've been the most successful when I pick a very specific problem and test and iterate on it versus trying to solve something that's very broad. Anybody else find it? Feel that way? Yes, I see lots of nods. So what if I'm not a deep modeling expert, and what should I be thinking about when I'm engaging in this world of small language models? So this is why we feel that tuning models is really the big developer skill of tomorrow. And thanks to the recent releases from PyTorch, ExecuTorch, and from ARM, it's even easier. There's a number of blog posts that have come out in the last week. Many you probably have read. And there's many simple ways to tune small language models. You can use transfer learning techniques like LoRa adapter tuning, soft prompting, RAG, prefix tuning, and instruction tuning, and parameter-efficient fine-tuning. And yes, you do still have to obviously pay to fine-tune, but that's an upfront cost that then saves you in the long run for very specific use cases. Now, when you're thinking about what you actually want to do when it comes to fine-tuning, there's a lot of decisions when you think through the strategy about what to do, and it goes back to your use cases. And you are the expert in those problems, and there's no one better to tease out that logic and make those decisions than you. So running through this table, and again, going back to my strategy hat, well, you have to really think about what are the resources that you have, and what compute, what data, and what time do you have. The number of parameters is directly proportional to the cost that you incur. So how much can you actually afford? When you think about the keynotes earlier today, is the data available to you on the interwebs? Is it available and easy, or is it something that you're going to have to go out and actually get yourself? So when it comes back to ARM is helping to tirelessly improve everything behind the scenes to ensure that your models just run best on ARM. So our goal a lot of the time is just to make it work for you. We do this through active support of the PyTorch Foundation, working directly with teams on things like ExecuTorch 1.0 release, which just came out, to help support things like optimization and quantization for models for edge deployment with minimal accuracy loss. And we're super excited to be part of the ExecuTorch 1.0 launch. There's several teammates here who've been directly contributing to that, so thank you for your tireless work. So that your torch models can now be exported and launched on top of offerings like ARM Lumex. So whether you're building for mobile, PC, wearables, edge sensors, or high-performance IoT, your workloads will automatically benefit from performance and efficiency gains. And when you're targeting devices built on ARM CPUs, GPUs, and NPUs, and this is through things like ARM Kleidi AI, TOSA, et cetera. And we have a whole suite of tools and componentry to ensure that we have a united efficiency where hardware meets software. So that includes this concept that efficiency isn't just software optimization or better hardware. It's really about this intersection of both. So we have ARM Kleidi, which delivers optimized compute primitives for PyTorch architecture operations on the ARM architecture. We have ARM Lumex, which is our compute subsystem, and we are ruthlessly focused on thinking through heterogeneous compute so we can help developers better distribute their workloads across any type of accelerator that they're building their model on. And again, going back to the small model concept, there is a massive benefit as well where there's different models might be running better on different types of accelerators, and that's a whole nother part of your strategy that you'll want to be thinking through as well. So, quick recap. ARM and ExecuTorch 1.0, small AI is the next big thing. Our operation costs are lower, latency and privacy for UX, you can fine-tune to specialize, and you can do so much more when you're actually at the customer's fingertips, when you're thinking about very specific, everyday, real human, useful tasks. And we are here to help. We are looking to help with better inference on devices with Kleidi and Lumex. We're working behind the scenes to try to help you as much as possible, so it just runs. A lot of the stuff that I'm talking about, many of you may not ever actually need to touch any of these components or these tools. We just want to make it work great for you. And we are deeply invested in the PyTorch community. ExecuTorch 1.0 is out right now. We are doing everything we can to automatically optimize behind the scenes for you on CPUs, GPUs, and NPUs. And again, this just works. If you check out developer.arm.com, you can learn more about Kleidi, about TOSA, and many of the Android app integrations that we have, so it just automatically works for you when you're building applications on things like Android. And plug for the remaining session that we have from some of our ARM representatives. Deploying LLMs at the edge, lessons from the field, is happening later today. There's a Birds of a Feather. And we also have an ARM AI Developer Challenge, so come check it out. And if you'd like to come and learn more about what we're doing, I'm happy to chat after. And again, please come talk to Yannis as well if you'd like to come and participate more in helping us to build the future of small language models on ARM. Thank you.